let's talk about one of the most maddening things about working with AI agents today, getting them to actually finish a big job. This explainer is all about a very special kind of memory called Nova's Episodic Task Memory, or ETM for short. It's designed to do one thing really well: make sure an agent sees its mission all the way through to the end. This quote really kicks things off perfectly. The report is the byproduct, not the goal. Now, what on earth does that mean? Well, it's a hint that we need a much deeper, much more rigorous definition of what it means for a task to be done. It's about moving past just getting a summary and into something that's actually verifiably complete. So that leads us right into our first big topic, what I like to call the agent's amnesia problem. Seriously, if you've ever tried to get an AI agent to do something complex, you have definitely felt this pain. They start out great, but they don't always finish the race.
So what's going on here? Why do AI agents just give up on complex tasks? They are absolutely brilliant at short, simple commands. You tell them to do one thing, they do it. But give them a long, multi-step job that requires real persistence, and they tend to stumble. They lose the plot, they forget the original goal, and they just quit way too early.
And this right here just illustrates the problem perfectly. I mean, imagine asking an agent to review a 120-page document. After checking just 17 pages, it comes back all confident saying, done. The thing is, the agent isn't being lazy. It's just that its memory, its understanding of the full scope of the task, isn't strong enough. It's confusing a little bit of progress with total completion. Okay, so how do we fix this? That's where Nova's Episodic Task Memory, ETM, comes into the picture. It's a system designed from the ground up to solve this amnesia problem by giving the agent a real durable memory of the task, not just what it's supposed to do, but how it's supposed to do it. So what exactly is ETM? Simply put, it's the agent's task memory. It's built to recognize jobs it's seen before, enforce super strict, verifiable rules for what complete actually means, and here's the cool part. It gets smarter every single time it's used. And the name isn't just a cool acronym. It's inspired by cognitive science, where episodic memory is our memory for personal experiences and events, not just random facts. Now, what's really interesting is seeing where ETM fits into Nova's bigger memory system. You see, Nova already has procedural memory, the PKS, which knows how to do things, like click a button on a website. It also has operational knowledge, or OK, which knows the current state of the world. ETM adds that crucial third piece of the puzzle, remembering what the task was, how the whole thing went, and what it learned from that entire episode. So how does ETM actually pull this off? How does it create this incredible reliability? Well, the answer lies in its 4-layer architecture, which basically gives every single task a solid, dependable blueprint to follow. So here they are, the 4 layers. You've got the task profile, the task instance, the effective task context, and the awareness bounds. Now together, these 4 ensure that every task is super well defined, its execution is tracked perfectly, its rules stay consistent, and the agent always knows what's going on. Let's dig into each one. All right, first up is the task profile. The absolute best way to think about this is as a master blueprint, or maybe a template, for a job the agent is going to do over and over again. It defines everything right up front. What's the goal? Is there any special guidance? And this is key. What are the exact rules for what it takes to actually complete the job? So, if the profile is the blueprint, then layer 2, the task instance, is the actual project being built from that blueprint. It represents a single, specific run of that task. This layer is all about tracking the nitty-gritty. Which little bits of work have been done, what's the overall progress, and what's the current state of the whole job? Okay, now this layer is absolutely critical for reliability. The effective task context essentially takes a snapshot of all the rules from the task profile the instant a task begins. Now, why does that matter? It means the rules of the game can't change halfway through. Even if someone goes and updates the master blueprint later, this specific job is going to follow the original instructions it was given, locked in from the start. And finally, layer 4, the awareness bounce. Think of this as a super lightweight little post-it note for the agent. Instead of having to read the entire massive project file every second just to know what's up, the agent gets these little compact, real-time hints to stay informed and on the right track. It's incredibly efficient. And this brings us to what is truly the secret sauce of ETM. It's not just about remembering the task. It's about fundamentally changing how we define the word done. It's about moving away from an agent's story about being finished to cold, hard, factual evidence.
What's crucial here is that ETM knows not all tasks are the same, so it offers three different but very strict definitions for done. For some jobs, it has to be exhaustive. Every single piece of work has to be processed, no exceptions. For others, a threshold is good enough. The task is done when some metric hits a target. And sometimes, you just need an exploratory pass, where checking a good sample is all you need.
Now, to make all that work, ETM tracks something it calls the discovery state. When a task starts, the state might be unknown. As the agent works and finds things to do, it becomes partial. But the most important state is frozen. That means the agent is confident it has identified all the work there is to do. The scope is now closed. And for an exhaustive task, you can't be done until that discovery state is frozen. This slide just puts it all together beautifully. The old way, it relied on the agent's story. The agent just says it's finished. The ETM way, on the other hand, is all about factual verification. ETM checks the state. Is the discovery frozen? Are all the little work units closed? Have all the mandatory checks passed? Only when the answer to all of those is yes is the task actually considered complete. So let's just zoom out for a minute and talk about the real-world impact of this. Why does this shift from a forgetful agent to a factual one matter so much? What's the big deal about having a reliable task memory?
Well, for one, this isn't just some idea on a whiteboard. See this number, 12? That's how many dedicated internal tools have been built just to support the ETM system. That really shows you the depth and the seriousness of this whole architecture. It's a robust, fully baked part of how Nova works. And you know what? All that investment leads to some massive advantages. With ETM, agents can finally recognize tasks they've done before. Progress gets tracked in a structured, reliable way that can survive interruptions. And most importantly, completion is enforced based on facts, not just an agent's claim. And because the system learns, the guidance and performance get better and better every single time a task is run. And that brings us right to our final thought. It's a question I really want to leave you with, because it gets right to the heart of why systems like ETM are so incredibly important for the future of AI. Think about it. If an agent can't truly remember its mission from start to finish, can you ever really trust it to finish the job?